Hello everyone, welcome to this video. In this video, we are going to talk about a problem which is called random pick with weight. It's a good problem. So let's start. You are given a zero indexed array of positive integers w, and wi describes the weight of the ith index. You need to implement the function pickIndex, which randomly picks an index in the range of 0 to w.length minus 1 and returns it. The probability of picking an index I is wi divided by sum w. Okay. For example, if w is equal to 1, 3, the probability of picking index 0 is 1 by 1 plus 3 is equal to 0.25. And the probability of picking index 1 is 3 by 1 plus 3, which is 75%. Okay. So, w- what we are given is we will be given in the input, we will be given an array which will contain keywords like solution and pick index. So if the solution function, so these are the function names. We can see the function names are solution and pick index. So when the solution function is called, it basically, uh, you know, this function is called. Okay, so we don't have to return anything in this function. As we can see here, when the solution function is called, we don't have to return, it will just print null. But when the pick index function is called, then we have to return some value. What value we have to return? This we are going to discuss now. So, for example, as mentioned in the example 1, 3 is given. So what we have to do basically is we have to generate a random number, okay, and we have to return the index. For example, 1, 3 is there. The index of 1 is 0. The index of 3 is 1. Okay. So what we have to do is uh, we will be given, like, we have to generate, we are given the this array as input. We have to generate a random number on our own. But what should be the random number basically? What should be the size of this? Or like, what should be the limitation of this? Like 1 comma 3 is given. All right. So let's forget about this random number. Let's come to this question. So if 1 in 1 comma 3, if the pick index function is called, okay. So here, what we have to do is we have to return an index, either 0 or 1. Okay. So it should be random. Like, like, forget about everything. Let's say that the probability uh, of getting index 0 and the probability of getting index 1 is 1 by 2, 1 by 2. Then if the pick index function is called, then we can return 0 or we can also return 1. These two indexes, any of the numbers we can return, because the probability of returning 0 will be half and the probability of returning one index will be half, right? So, but in this question, there is a twist. Here, the probability is changed. Okay. So, here, what it is saying that here the probability won't be 1 by 2, 1 by 2. Like, if we call the pick index function, the probability will not be like 0, will be called 1 by 2. 50% probability is that. 1 being called will have the probability of 50%. It's not like that. The probability of returning an index will depend upon the weight of that index. So here it says that the probability of returning 3 will be greater than the probability of returning 1, right? That is the thing. So that is what here it's given. S- What, but how we will get the probability? We can get the probability of 1 divided by 1 plus 3, and the probability of returning 1 index will be 3 by 1 plus 3. So it will be 25%. It will be 75%. So most of the times, one index should be called uh, because it has a probability of 75%, which is determined by its weight, which is equal to 3, right? So this is the uh, question. Uh, but anyhow, 0 or 1, anything can be returned, but the 1 should be returned more as it is having more probability of 75%, right? So how we are going to do this, right? Suppose we are given an array of 1, 4, 3, 2, okay? So we can say that the probability of having 4 will be greater than 3, then greater than 2, then greater than 1, right? So how we are going to return this index? How we are going to do this? How we are going to return, I mean, if the pickIndex function is called, this index should be returned. Like based on the probability. For example, w is equal to 1, the probability of picking index 0 is okay. This. It does not mean that 0 won't be picked. 0 will be picked. In certain cases, we will get the answer as 0. But uh, but here you can see most of the times 1 is getting returned. So the answer is not fixed, as we here we can see all of the following outputs can be considered correct. But we should have the intention clear, like uh, if the pick index function is called, then majority of the answer will be falling at this index as compared to 1 or 3, 2. So how can we get the intuition of this? So the intuition can be like 1, 4, 3, 2 we are having in the array. Okay. And what we can do is, what is the sum of this? Let's have the sum. 1 plus 4 is 5, 5 plus 3 is 8, 8 plus 2 is 10. So the sum is 10, right? Let's have an array of 10 size. Okay. Like, it's like 4 members are there. This one has more energy, more money. So he will buy, and this is a house of size 10. Okay. So as 4 is having the maximum money, so it will occupy the most of the spaces. But how? Let's see. Let's make rooms in the house. Okay. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So as discussed, the 1 index 0, which is having the value 1, is having the least money, which is equal to 1. So you should occupy that many number of blocks in the house. So 0 is having 1. I mean, so it will occupy only one block. So index 1 is having 4. So this 4 will occupy how many blocks? This 4 will occupy 4 blocks. Okay. So I'll write the index here. Okay, so the index is 0. So let's grab it. We won't write the money. We will write the index. Index represents the name of the person. This represents the money it is having. So what we will write in the room, like the room will be having the index as the identity, right? So the index is 0, which will occupy only one room. The index So what about index 1? It is having 4, money 4. So it will occupy, 1 will occupy 4 rooms. So 3 in the index 2, which is having 3 rupees, for instance. So it will occupy 3 rooms, and the index 3 will occupy this. Okay. Well, there is no need of this. Right. So this is the thing. Now, okay. Now suppose we have a random number. Now just suppose a pick index function is called. Okay. So index function is called. So which index out of 0, 1, 2, 3, which index should it pick? Uh, that we have to think of. Okay. So how we will think of that? We can think of that by we will generate a random function, random number. Okay. We don't know, like we know the probability of everything, but what it should return. Okay. Suppose we are playing snake and ladder or something, right? So we throw a dice, then we get some value. Okay. And based on that value, uh, the function executes, and the dice goes somewhere. I mean the the dice which we are having goes somewhere, goes to some number, and that it returns that number. But we throw a dice, right, to get that number returned. Okay. So here we have to do the same. We have to throw a dice first. Okay, so that it's not like the pick index function is having any integer as the input, and based on that integer we have to return the index number, either 0, 1, 2, or 3. So it's not like that. We have to generate that index. Okay, we have to throw a dice, and then we have to get that number, get any get the number returned. Right. So to throw the dice, we have to invoke, like we have to have a random number, right? We have to generate a random number. Okay. So, okay, now we know why we have to generate a random number. The second step is what should what should be the random number? What should be the till what magnitude the number can be? Okay. So here we can see we have the 0, 1, 2, 3 index. Okay. So the room numbers are from 0 to 9, right? So we throw a dice, and we don't know, we have to return the identity of the person. We have to land in some room, right? Suppose, and we have to throw a dice within among these numbers. One we will get, and based on that we will get to some room. Suppose we get 5. Okay, as we throw a dice we get 5. We go to this room, then who is present in that room? 2 is present, right? So we'll return 2. Okay. So the magnitude of the dice should be from 0 to 9 here. That will be the sum of this. So random number should be within the total. Now this we have got. Now, yeah, the second step is also success. The first step was why random number we have to generate. The second step was what should be the maximum magnitude of the random number. So those two things are complete. Now we will throw a dice. We will get some, get into a room, and will return the identity of that person who is living in that room. Right. But there is one drawback which which we can fix in future. The drawback is Suppose, so when we see the constant, we see that the value of the wi can go to 10 to the power 5, which is very huge. So will we make an array of length, of so much length? Is it advisable to make an array? It will consume a lot of space, right? So this is a drawback. And how we will fix that, right? So we had generated this array, right? So instead of generating this array, can we do something which will have the same mechanism? Like we will throw a random number and we have to return the identity of that number. Okay. So if we closely observe this array, we are having 0 as the first element. Then 1 is occupying the four rooms after 0. Then 2 is occupying 3 rooms. And then 3 is occupying 2 rooms after that. Okay. So these are what indexes, right? 0, 1, 2, 3 indexes are there. So let's have 0, 1, 2, 3 indexes, 4 rooms, like 4, 2, 3. This is index 0, 1, 2, 3. Now here 0 index is occupying one room, right? 0 index is occupying one room. Okay. Earlier what we had in the array 1, 4, 3, 2. Earlier, let's take this reference 1, 4, 3, 2, right? 0, 1, 2, 3. 0 was occupying one room, 1 was occupying four rooms. Okay. So what we will do is we will uh, generate a prefix array. Okay. We'll discuss about why this is needed. Suppose so prefix array will be 1, 5, 8, and 1, 4 plus 1, 5, 5 plus uh, so first element is there in the prefix array as the first. Then the second element in the prefix array will be the first element plus 4, which is 5. Okay. This element will be 5 plus 3, which is 8. Then this element will be 8, previous prefix element plus 2, 10. Okay. Now, instead of having this big array, we have the prefix array with us. Okay. So how are we going to what we are going to, so suppose we are having a random number. We are having a random number in the range of 10, 0 to 10 as discussed. Okay. So 0 to 10 is, it will be basically 0 to 9, right? Of size, it will be of size 10, but the value should be inclusive of 0 to 9, right? So suppose we generate 8 as the random number. So if we go to this array, the eighth room is having three third index as third index is occupying the eighth room. So we would return 3, right? But in the prefix array, 8 room is this. This is the room. So what we will do is we will print the index of the person which is coming after that block. Okay. Suppose we get room as 6. So here 6 is having 2 is staying as 6. So 2 is staying at 6. Okay. So we should return 2 as the output. So let's observe what is happening. So 0 is occupying 1. 1 identity 1 is occupying from 1 to 4. 1, 2, 3, 4. So and 2 is occupying 5, 6, 7, 8. 5, 5, 6, 7. And 3 is occupying 8, 9, 10. This is what prefix array means. 0 is occupying 1, 1. 1 is occupying One is not occupying anything. Like one is occupying index one is occupying 2, 3, 4. Okay, this is what prefix array means. This thing. Now, if we have six, okay, so six is occupied by what? 0, 1, 2. Two is two occupies six. Now six falls between this, right? So whatever in the array, prefix array, we are having just greater than six, we are having eight, right? So eight is at which index? It is at index two, right? So we print 2. So we print that number which is just bigger than what we have got through the disk, right? The identity of that number we have to return. Suppose we get 4. So 5 is just greater than 4 here. So we'll print 1, right? So this is what we are doing here. And uh, this we can do via binary search technique. It will save a lot of time, 1, 5, 8, 10, instead of we could have gone line by line. I mean, from first to the last element in a linear search uh, pattern, but it would have taken O of n time. So by binary search, we can take O of log n because it is already a sorted array, right? So let's see how we can have binary search here. So suppose we are getting 6 here. Okay, so 6 is between 5 and 8. So what we can do is how we'll get 8 as the answer. 8 as the uh, uh, value just greater than 6 in this array. So suppose we take L low here, this will be high here. Okay, mid will be this. Now 6 is greater than 5. So what we'll do is we'll have low variable mid plus 1, and the new mid variable will be this. Okay, so now 8 is greater than 6, so this may be the answer. So we will have the answer, we'll store 8. Okay, we will not store 8, actually we will store the index of it. That is what we have to return. So index of 8 will be 2. This we will store. So this is what, this is mid. And then uh, what we'll do is we will have, as it is greater, then we'll check if there is some element which is smaller than 8 but greater than 6. That we will do by having high is equal to mid minus 1. So then the high will become here. But high is lesser than low, which should not happen. So we'll come out of the loop and print the answer which is having the 2. So in this way we can solve using binary search technique. And yeah, let's solve this using uh, let's code this in the on the lead code. Uh, First of all, we want prefix array, right? So this is prefix. We also want to have length as a global variable. So here the length, first of all, length will be w.length. Okay. Now we have to prepare the prefix array. So let's prepare the prefix array. Um, int I is equal to 1. We'll start from 1 because we have already stored 0th element above. Here we have the prefix of I equal to prefix of I minus 1 plus W of I. Now we have the prefix array as the global array. What we have to do is we have to, this is the main function pickIndex. We have to return the index. So let's take in the buff, we have to perform binary search here. So let's take low as 0, high as what should be the high? In this case, the high is 10. What is 10 basically? The prefix array is this. So the 10 is the last element of the prefix array. So until that time only we have to, that is the maximum magnitude of the prefix array. So that we can do using prefix or length minus 1, right? Now we have to generate a random number. So random number will be of double because it may or may not be integer, right? That is the thing, we cannot take it as an integer as it will give a wrong answer. So double will be math dot random double what? Double, let's take R, math dot random. Uh, okay, this is the inbuilt function into what should be the range of the random function, magnitude of the random function should be uh, like in this example it is 10. Okay, so it should be like 0 to 9 as discussed, inclusive. So what is 9 basically? What 9 is like this only prefix length minus 1. So we should have random number in that range. Now we have low less than is equal to high. We have to calculate mid, which is the index. Uh, okay, okay, index of the no mid is not index actually. Let's take it should be like low plus high minus low by 2. Yeah, it will be it should be index actually. So if it is an index, yeah, it will be an index. But high, okay, high is this. Okay, low, then high should be length minus 1 because in the binary search we have to perform from here to here. This is the length. High is the length of the array. Okay, length minus 1. Right, now we have the index as mid. We have to store it in the answer. So answer we can take as 0 because by default we can take 0. If what is the prefix? We have stored the prefix array as the global array. So if the prefix of array, if it is greater than a random number, it means that we have, for example, we are in the 8, this side we are having. Then what we have to do, we have to store it in answer first to be on the safe side. It may be the answer, and then we'll check further by going low. High is equal to mid minus 1. Okay, and then what we will do is if it is less than equal to, then we have to search more by going low is equal to mid plus 1. So this is how, and we'll return answer. So this is the prefix, this is the pick index function. Let's see whether we have written it nice correctly or not. So yeah, it's fine by now. Um, okay, let's run it and see if any error is there or not. And the time complexity will be O of log n, null pointer exception, because this dot prefix is null. We have not initialized a okay, yeah, prefix array here, new int length. Oh, it should be of size length. Okay, so I was talking about time complexity. It will be log f n. The prefix size will prefix I minus 1. Okay, we have to we have already stored 0, 0th index here. We don't have to do it again. It should run. So yeah, it's running. So the time complexity will be log of n because we are performing a binary search. We could have done it in the log of in O of n time, but if the binary search is there, then why not do it sooner? So this is all about this video. If you found this video informative, please like this video and subscribe to this channel to get more updates, and please share it with your colleagues. We'll see you in the next video. Thank you.